an emergency situation. Oh my God, how you doing?
What are we learning?
Oh,
Oh, that was really fun.
Oh my God, really?
Thank you. You can blame us.
All right, so me.
Or not.
How are you, Miss
Oh.
Peachy? Y'all gonna put over here?
Why don't you lead us into yoga? Good to see you. Hey. Hi, Matey. How are you? Did a lunch session. That was really good. She was like, Matey at the SC. Oh man, I get to present it. She's lovely. She pregnant? By then? I mean, don't make the obvious comment. Everybody is. Yeah, okay. I think but so close. All right, it's 3:15, so we will get started. I am Carrie Rosenkrantz, Program Director at Dartmouth, and I'll be co-moderating with Dr. Amit Joshi, who is a professor of surgery as well as the Associate Dean of Graduate Medical Education and the DIO at Cooper School of Medicine in New Jersey. So for anyone who's looking at this title or anyone who looked before the meeting, if you're anything like Amit or me, it might have been very daunting to you. You might even have looked up the letters as we did. So LLM, large language models, and NLP, natural language processing. So that's what we've learned to moderate this session. Hopefully by the end of the session, I should say, I'm certain by the end of the session, because we have some great panelists, all of us will have much better understanding of what is really AI, how we can use it for resident recruitment, how our students and our residents are using it, and how we can use it for assessment within our programs.
So first up is Dr. May T. Dr. T is a surgical oncologist and associate professor and program director of surgery at the residency at Howard University, and she's going to be talking about the use of AI tools for program recruitment of prospective residents. Thanks, Dr. T.
All right. Thanks, Carrie. Thanks, Ruth. So thank you to the APDS board and program committee for the invitation to present today. My name is May T, and I will be speaking about the use of AI tools for program recruitment of prospective residents. I have no disclosures. So this presentation is going to be divided into three major topics. The first part will be a brief introduction about the terms AI, LLM, and NLP. The second part will be about AI tools that are currently available for program recruitment. And the third part will be a little bit of data that has been published from our institution about these AI tools for program recruitment. Part 1, AI 101. So before I define AI or artificial intelligence, I just wanted to acknowledge the Georgetown Howard University Collaborative and NIH's Aim Ahead for their assistance in preparing these AI 101 slides for me. In a nutshell, though, AI can be defined as intelligence exhibited by machines or software. Okay, that's what AI is. There are many forms of AI. NLP, NLP, or natural language processing, is a field of AI that focuses on the interaction between computers and human language, enabling machines to understand, interpret, and generate natural language. There's also another form of artificial intelligence called foundational models. Now, these are large pre-trained neural network models such as GPT-3 or BERT, and they serve as a point for various natural language processing and machine learning tasks that can be fine-tuned for specific applications. Now, GPT-3, as you know, is owned by OpenAI, ChatGPT, and BERT is basically Google's form of natural language processing and LLMs. Okay. So what is a large language model? So a large language model is considered large because it is trained on a massive amount of data. In a simplified LLM neural network, so to speak, data inputs are broken down to things called tokens, which are then analyzed and interpreted by the machine to generate outputs. While the machine itself is unbiased, the information going into the machine is coming from a biased world, and thus there's a risk of machine learning propagating such biases. Okay, more on that a little bit later. So what are the tools available for recruitment? What are the AI tools available for recruitment programs? So all of the AI platforms that I'll be showcasing use natural language processing and large language models that can facilitate reading a residency application, which, as you know, can be multiple pages long. It can then generate a summary and impression of a candidate. There's free software widely available, and that includes OpenAI's ChatGPT, Microsoft Copilot, and Google's Gemini. However, these software tools do not have interfaces with AAMC ERAS, and thus you'd have to manually input each application to these software platforms. Thalamus and Medicratic, however, are AI natural language processors and large language model software that do have interfaces with AAMC ERAS. So let me talk about first Thalamus Cortex. So in the 2025 match cycle, all residency programs had access to Thalamus. And as we saw in Alphabet Soup, 90% of programs adopted Thalamus nationally. There's also something called Thalamus Cortex, which is available for a subscription and which our institutional GME purchased for all Howard residency programs. Thalamus Cortex uses natural language processing and large language modeling to facilitate efficient holistic review. The data from Thalamus suggests that it can decrease screening time by 50%, promote DEI recruitment efforts through this facilitated holistic review, and the AI-assisted technology has a greater than 95% accuracy in holistically reviewing these applications. So this is what the Thalamus Cortex program looks like. It has the applicant name, and picture. It has whether the applicant signaled you in terms of the division or preference. It has all of their scores very nicely laid out. It also tells you whether they've had any failed attempts on any of their USMLE boards. It tells you whether they're involved in any honor societies. It extracts their dean's letter and their transcript to give you standardized grades. And it also gives you their medical education history as a nice continuum. It's all very neatly summarized, literally a snapshot of the candidate. And as a disclaimer, I did use Thalamus Cortex for the 2025 match cycle, and I was very, very pleased with it. Medicratic Halstead is another AI company that features selection software called Halstead. It was founded by 2 US medical students and 1 coder. So how Halstead works is that a residency program director can input all of the AAMC ERAS applications it receives. So you basically just batch download the PDFs and you can upload it on the Medicratic Halstead server. Following a training session with the PD, the Halstead AI reads every word of every application and it looks for key characteristics in the personal statement, CV, and letters of reference that the PD is looking for, like grit or resilience. And it ranks every letter of reference in general and by letter writer. So what do I mean by that? if Dr. T wrote a reference letter for X, Y, and Z candidate, it would rank the strength of Dr. T's letter for X, Y, and Z candidate in that algorithm, as well as Dr. T's letter compared to every other letter writer across the country within that applicant pool, okay? And it can generate a rank order list of the applicant pool that you upload that you want it to rank. So this is what I used in the 2024 match cycle. So these AI platforms are very promising. There's a huge problem of increasing application volume, which has been partially mitigated by preference signaling. This may or may not be a sustainable solution, as there are an increasing number of medical schools that are opening. So as you can see here, in the 2024 match cycle, there were 44,000 applications for a total of 41,000 residency positions. In general surgery alone, there were 1,700 positions for over 3,000 applicants. And for our program, we received over 1,200 applications for only 9 PGY1 positions. So there are significant benefits that may come with AI software. For instance, with the USMLE Step 1 being pass-fail, there's a greater emphasis on holistic review. And in our experience, the average application screening takes about 10 to 20 minutes per applicant. And with program directors competing clinical, teaching, academic, administrative duties, it's just really not possible for a single program director to review every application it receives. In fact, we calculated how long this would take for me to review all 1,200 applications to screen for interviews, and it would take 26 8-hour workdays without breaks to review every single one of those applications. So it's just not practical. Now, to contrast that, when I uploaded all 1,200 applications to Medicratic Halstead, it ranked application number 1 to number 1235 within a matter of hours. I literally uploaded it one evening, went to bed, and the next morning I had a rank order list from 1 to 1235. Now, the AI software also considers many applications characteristics which promote diversity, equity, and inclusion. It can emphasize certain things on your personal statement and letters and recommendations. So in that sense, it tries to simulate true holistic review. So what are the potential risks of AI software? First of all, this is relatively new technology. It's not well tested, and it lacks robust independent research data to support it. Now, while the AI software runs on a computer algorithm and a computer is a machine, the algorithm is still built by humans with inherent biases. Now, literature on AI facial software has shown that there is decreased recognition of Black people compared to white people for facial recognition, and that is because of their underrepresentation in machine learning. There could be similar biases that we don't know about or totally understand with natural language processing and large language models. So if a computer learns based on the information it is given, is it really unbiased? So I want to end off my presentation just by sharing some of the data that we published as a program. This study was published in the Journal of Surgical Education at the end of 2024, and it examined the 2024 match cycle. So I trained the Medicratic Halstead software, which was its very first version, and it was available to all programs at that time for a free trial period. I sat with the founders of Medicratic Halstead for about a 2-hour initial Zoom session, and I trained Halstead on the type of candidate I was looking for. So it would ask me hypothetical scenarios about whether I preferred applicant A to applicant B. And it was kind of like Tinder. You just swiped one way or another. And based on that, it was able to learn what my ideal candidate was. Now, I didn't entirely rely on Medicratic Halstead. I also performed a parallel screen the normal way that I would do for recruitment. I used USMLE board score cutoffs, and I looked through, I used various ERAS filters, and I created a top 150, 100 list of people that I would screen for potential interviews. So based on that AI training session, these were apparently my PD preferences, which I actually thought was pretty accurate. Based on this, I had an overall balanced weight towards personal statements, research, medical school, letters of reference, personal qualities, and board scores. Those are the things that I wanted emphasized on my review. Now, I screened 144 applicants for potential review that met my filter cutoffs. And then I compared it to the top 150 applicants that were ranked by the AI software. And surprisingly, there was only a 20 applicant overlap, which was 77% of the overall pool. So then we wanted to see what the differences were in the applicants that the AI selected and what the differences were in the ones that the program director selected. So the first analysis showed that there were some differences by graduation year, visa sponsorship, US graduate, program signals, and number of publications. And we delved into that a little bit more with another analysis where we just censored the overlapping cohort just to reduce the number of noise. And what we saw was there were significant differences with the AI software selecting more recent medical school graduates, younger applicants, more US medical graduates who did not need visa sponsorship, less program signals, and more publications. Additionally, the AI software preferred applicants with higher step 2 CK scores, and there were some differences in race and ethnicity. There was a slight propensity of the AI to prefer white and Hispanic applicants. And not surprisingly, as a PD of a HBCU, there was a slight propensity for me to prefer Black applicants. So there are, of course, a lot of study limitations. This was a single institution study at a historically Black college and university. And the selection was done by just one program director rather than a group of faculty. It was the first year of this program being used. And it was also the first year that signaling was used. And so I do feel like I underestimated the importance of program signaling when I trained the AI initially. One of the other limitations is that the AI software is proprietary and there's no way to access the software code or algorithms for further study. There was also no way for me to personalize it by looking at, say, HBCU medical graduates, which we rely on heavily as an HBCU residency program to train. So the other thing was that my review, you can argue, was not truly holistic in the sense that I was still using AAMC ERAS filters, which was just the usual way that we did our applicant screening. So our main findings was that there was only a 7% overlap. One of the benefits of the AI software was that it did select some applicants that were filtered out by my initial review. So I did look at some of those people, especially the highly ranked ones. The AI did tend to select applicants who were younger, US grads, had higher step 2 scores, more publications, and possibly more white or Hispanic applicants, although it's hard to say as someone coming from an HBCU program. So what we concluded based on that initial trial was that while AI screening is a useful supplement, it should be supervised by human review and shouldn't completely replace it. So in preparation for this talk, we wanted to reevaluate the platform for our 2025 cycle and compare that with our usual review, as well as our use of thalamus cortex holistic review. Now, my APD, Dr. Nemhard, had just secured funding for us to pay for the $6,000 subscription fee for this Medicratic Halstead program for 9 interns. And when she went to log on, we were a bit surprised to see these updated terms of service. So we're not allowed to do research on it without written permission. And so I didn't get written permission, so I can't share any of our data from 2025 quite yet. But there is the potential for a multi-institutional study evaluating the impact of AI on applicant screening and recruitment, which is endorsed by the APDS Research Committee and that Dr. Carrie Ahrens is trying to coordinate. So just a plug for that. Thank you, everyone. It's been a real privilege and honor to share this data.
Thanks to Dr. T for a really great talk and making this understandable, which is appreciated. Next, we're going to hear from Dr. David Spain. Dr. Spain is an acute care surgeon at Stanford, where he is a professor of surgery and the program director. He'll be talking to us about what students and residents are doing with AI.
Thank you. Yeah, we're going to talk a little bit about this. So I'm an old guy, right? So I don't know anything about this stuff. So I just went to my 2 residents, Josh and Taylor, who are informatics fellows, and I said, I need help. And they're like, okay, sit tight. We'll make you a slide set. So I have a slide set for my residents, so easy enough. But we'll talk a little bit about what they're doing, or at least what these two think we're doing. So I have no relevant disclosures, except I will tell everybody that we just opened a search for a vice chair of education that I'm running. So if anybody's interested in looking at a job as vice chair of education, find me and we can chat. So, currently about 40% of adults are now saying they use generative AI, but it's really although they use it, their use is infrequent. So it's only in about, 4% of their work or less. So I think the question is, how are surgery residents engaging with this technology? So we did a survey of our residents, and like 20 of them responded. About half of them were PGY1, so 26, 27-year-olds. And most of them were using it for sort of non-clinical stuff, which was a little reassuring. So again, academic writing, about half of them. Personal writing, so applications, letters. We had some discussion yesterday in one of the papers about people using AI for personal statements, literature review, coding or research assistance, studying and board prep were being used. Some of them were using it for language translation, not for clinical care, but outside of that, and then just task management and scheduling stuff. So pretty mundane stuff. Some of them were using it for clinical work, a small portion, but generally not direct patient care. So some of it was for creating educational material to give to patients. So, explanations and the like. Occasionally answering clinical questions, which makes me a little bit nervous. Language translation, again, also probably not, unless it's truly supervised, a little bit problematic. Some of it for drafting clinical notes, and then a little bit for generating differential diagnosis. So again, using, the computer for help is probably the latest thing and what's going to be happening. Most of them were using free stuff. A few of them were using a paid prescription, but most of them were just using free access that most of us have, again, through the hospital and the training program. And then again, the majority of them were only using it for maybe 30 minutes or less a day, so it wasn't super frequent use. Not unexpectedly, ChatGPT was the most common thing that they used, readily available, free. And so that was common use. And but a quarter of the residents said they hadn't used it at all. And then again, there's varying level of sort of interest and comfort with using it. Most of them were interested and thought, they wanted to use it more, but some were extremely uncomfortable using it. Most were, somewhere in the middle, and a few of them were extremely comfortable using AI tools. Yeah, I think one of the more interesting things that they talked about is the need for training. We talked about this a little bit yesterday in some of the papers. So I mean, what is coming? It's going to happen. This is, to me, this is like the robot, right? Like, we can fight it, but people are going to be using the robot in the OR. People are going to be using AI. So how do we use it responsibly? And I was at a meeting a little while ago, and somebody said, it's not that AI is going to replace radiologists. It's that radiologists who use AI will replace radiologists who don't use AI. So I think this is what's going to happen. So if it's what's going to happen, how do we educate our residents? How do we train them? How do they use it responsibly? So again, I think, some of the concerns and pitfalls really are inappropriate use. So right now, answering clinical questions using AI, probably not a great idea. Or medical document translation, also, again, probably not a great idea. Although I will say, having used an in-person translator the other day in clinic, I'm not so sure they did a great job either. But I do think, at some point in time, we will be using it to answer clinical questions, and it's really, how do you do that? So, I think you're always going to have some human in the loop. Currently, that's legally required, because you have to have a way of, verifying the accuracy. I think there are some concerns of HIPAA violations, like, there's a temptation to use non-PHI safe applications for medical tasks. I think it's a huge risk. And so I think there's going to have to be some institutional like limitations to, use of like large language models and the like. And then again, I think over trusting the output or the results, as we said, like Métis said, there's a risk of bias in these things. Like it'll be unbiased in how it analyzes the data we give it, but is the data we give it biased, right? And so I think there you have to be careful about that. Misinformation, and then obviously proofreading. I don't know. My only experience with ChatGPT is that I asked it to write a biography of me, and it said I was a critical care anesthesiologist. I was like, that okay. It's kind of close, but not really accurate. So again, I think some of the more interesting things that are going to happen is sort of the assist and assess, like in the OR, especially as we do more robotic surgery and more image guided surgery. The opportunities for these things to give intraoperative guidance and feedback are going to become more prominent. So how do we do this? And how do we use this for maybe skill assessment, but also intraoperative guidance and assistance. And that's going to require a lot of high fidelity simulation using real world data as well. And I think it's starting to happen already with some of the targeted robotic trainings that Intuitive is talking about. So what's our responsibility? It's going to come. I don't think we can stop this. It's going to happen. So how do we make sure that we do this safely and responsibly? I think there does definitely probably going to need to be some general guidance for residents and how you do this. So maybe it's a score module on how we use AI in clinical care and education. Definitely has to be some institutional policies, like what does your hospital do? And then, right now, probably the best resource you have are librarians and informaticians at your institution that can help you. And I think you're going to have to figure out like what is the PHI safe large language model that your institution can support. Thanks.
Thanks so much, Dr. Spain. I'm delighted to introduce our next speaker, who's Dr. Daniel Hashimoto, Director of the Penn Computer Assisted Surgery and Outcomes Laboratory and an Assistant Professor of Surgery at the University of Pennsylvania. And Dr. Hashimoto will be talking about skills training and assessments.
Right. Thanks, everybody, for the invitation to come to APDS and Surgical Education Week. I really appreciate it. I don't have any company-related disclosures. I have several grants. I'm an inventor on a couple of patents related to AI, but I'm not going to show any of that work today. All right. So with the great introduction that we've gotten so far already about certain types of AI tools that are available both commercially and sort of in the research space, I wanted to just provide some examples of what different groups, even groups here in the audience, have investigated in terms of looking at how we can use artificial intelligence to do assessment, both at the UME and at the GME level. So at the UME level, the UT Southwestern group, Danny Scott's group, has been doing a lot of really fascinating work incorporating things like large language models into assessing clinical encounters with the medical students. So this is a paper that came out last year in the New England Journal of Medicine AI, which is the NEJM's AI-specific journal, where they were able to look at grading of OSCE documentation by the medical students. So taking their encounter that they'd had with their standardized patients, splitting them up, looking at their notes and comparing the grading of the notes by large language models through a closed endpoint, like Dr. Spain had mentioned. So it's within the health system's computational structure, and then comparing that to the grading that was performed by human evaluators. I think what's important when you think about how you may want to incorporate large language models into doing assessments, the large language models, as sort of magical as they might seem in the way that we interact with them and the way that we ask LLMs questions, is at the end of the day, they're still quite limited in the types of reasoning tasks that they can perform. And so to be able to do something like an assessment where you want reproducibility and reliability, you have to craft the instructions in such a way that these models can look for concrete examples within the written text or whatever data you may want to put in to do that evaluation. So some of the things that they were specifically looking for would be, the way the prompting was set up is, well, here's the note, here are the context of what findings were noted for the patient. Find evidence in the note that this was reflected, that this clinical finding was reflected in the note. Is that finding there? Yes or no, right? And so you can sort of get a sense of, are students appropriately documenting their encounters, or are they missing findings that may have been presented? And so when this was rolled out from a research perspective, the first pass, normally 2 human evaluators, right? So first pass is let the AI grade everything. Take the low scoring students and move them on for human review, right? So here's that synergy between human review and machine review. So of that initial group, 17% of the students were flagged for human review. And that second pass human grading, when you look at the item level for each of the different findings within the OSCE, 90% agreement between the humans and the AI. The 10% that was flagged for adjudication went to a senior reviewer. That senior reviewer, I like the presentation of this in the figure, 32% AI win rate, or 70 or 68% human win rate, right? We gave the AI a lot of credit here. It's about how you spin certain things. Overall, there was 93% AI human agreement at the item level, but when you look at those items where there was disagreement and a senior human had to come in and step in, most of the time that senior human agrees with the human being, right? And so while overall the numbers, and I'm gonna talk about this at the end, the numbers look really good for the performance of the AI, you do have to dig in deeply to better understand how these things are functioning, because in the areas where there is disagreement, tends to be that humans will agree with other humans more. They've done a lot of work also in the technical skills realm, right? So being able to use things like computer vision to assess how medical students tie knots. So trying to classify or detect things like errors in the way that medical students are holding their instruments when they're not tying, the way they're doing their knot tying, and then giving them a formative assessment, even though it looks summative, but it's for formative purposes, of pass or fail on how they're doing their knot tying techniques. Other work that's being done in Chile, for example, is using vision language models to provide feedback on sort of broader tasks, right? So here you see the layout by Professor Julian Varas Cohen in Chile, where they're giving feedback on CPR. So you can see here, the large language model can generate an initial suggested feedback. Human being can then step in and give more specific feedback about what's happening. And so now you have like video-based review that is augmented by a large language model. When we think about interoperative training and assessment, there's been a lot of work, particularly in the research space, done with this. Not so much of this has been done with large language models. Vision language models right now are really not very good at doing sort of specific honing in on parts of an image or a video. But a lot of this has been done with traditional deep learning. And ways that we have tried to incorporate that have been by leveraging educational tools that may have already been used by residents rather than having them reinvent the wheel. So this is work by Amin Madani, who's an endocrine surgeon at UHN in Toronto. This is a web-based platform that presents a video, a little case vignette, and then subsequently pauses, asks the residents, if you were doing this gallbladder, where would you start your dissection? They can then mark it. They're able to go and see and compare themselves to expert submissions to see how they differed in their visual perception of the operative field. We were able to take those labels by the experienced surgeons and feed those into a deep learning model for computer vision purposes. So now what you're seeing on your right is basically a GPS of cholecystectomy, where in green you see the safe zone of dissection, in red is the unsafe zone of dissection, and now this becomes sort of a paint by numbers type of approach to doing a gallbladder. And we've since sort of expanded this work and included actually cases where there were bile duct injuries. And 9 out of 10 times, if individuals had had this type of a system, they would have avoided that. Not surprising when you think about actually some of the more historical literature, like Dr. Wei's paper from the early 2000s about how visual perceptual errors are what lead to bile duct injuries. And so if you can augment our ability to have visual perception, could this improve our performance in the operating room? Sort of to make that more accessible, while that particular software is actually now in clinical trial in Toronto, so it's being used in the live operating room to assess how it changes decision-making in the operating room. You can try this out yourself. So there's an iPhone or Android game that's been made out of this, where you can download this and it will give you a series of lap chole cases where you can compare where you would start your dissection relative to sort of AI trained safe and unsafe zones. Other work that's been done in France at the IHU in Strasbourg has tried to build in some feedback mechanisms. So number one, helping with review of video so that you don't need to watch an entire lap chole. It can automatically find for you the relevant part of the case where the critical view of safety was most likely achieved, or where surgeons sort of made that determination that it was a critical view of safety, so that you can just watch a targeted segment. And then you can get computer vision feedback on whether or not you achieved all three criteria of the critical view of safety with automated highlighting of the critical structures like the cystic duct, the cystic artery, the cystic plate, et cetera. I think what's really interesting is how this has evolved is actually now thinking about not just can you find structures, right? Our algorithms are very good where if somebody asks me, oh, I want to do a study, can I find this nerve? The answer is probably yes. You can probably find anything you want with these computer vision models. The question is, so what, right? How does this relate to outcomes? So this is work that's done by Andrew Hung at Cedars-Sinai. He's a urologist that looked at nerve-sparing prostatectomy. What you're seeing on the left is a series of dissection gestures that were identified by this group. Each of these colors represents one of these structures. On the upper right-hand corner, each row is a patient. It's a patient's operation, the gestures that were used during that operation. And what they were able to find is that the sequence of gestures that you perform during the nerve-sparing part of this prostatectomy correlates with erectile function outcome 1 year later. Right? Not surprising, technique correlates with outcome. The interesting part is they were able to identify which of those gestures correlates with preservation of function. So what do we know? Dogmatically in surgery, we know that we don't want to use our bovie around a nerve, right? You get thermal injury, electrical conduction, and so you might injure that function. But now we have the quantitative values that demonstrate that, yes, actually there is a quantitative difference in the recovery of that function. So this paper just came out this month, actually, in JAMA Surgery, where they're able to look at these gestures and found which gestures are protective of maintaining that function, right? So doing a lot of blunt dissection, not using energy around the nerves, and not surprisingly, what is more likely to lead to loss of that function, using energy, coagulating, physically grasping that neurovascular bundle. But now what you can do is you can take those color graphs and say, well, let me compare your sequence of gestures to the surgeon who has a better rate of erectile function recovery, right? So now you can start to incorporate these types of automated gesture recognition to provide feedback to practicing surgeons to give them some sense of how they can improve their technique to get better outcomes for their patients. We're doing similar things where, you don't want to be sort of locked in to the ecosystem of a particular company who wants to sell you back your data. And so we try to think about how we can use some of that existing data like video to infer some of these things. So this is work being done by one of my postdoctoral fellows. This is a robotic Whipple where you can see we're automatically tracking by vision only the position of all of the instruments, the needles, where the needle goes in, where the needle comes out. We're able to then do some 3D geometry around inference and actually assess how is the individual resident holding that needle, where along the needle are they holding it, and where do they fall in the distribution relative to an experienced surgeon, and how does that impact the outcome of the patient? Did they have a leak? Did they not have a leak? So we can give much more granular feedback about their technique and actually show them how they compare to others. This also applies outside of the intracorporeal view. Nasir Nawab in Munich has been doing a lot of work with 3D cameras in the simulated setting. So this is a simulated OR. The room is mounted with what we call RGBD or depth cameras, where this basically becomes a little bit like the cameras that you see in the NFL, where you can see a play from 360 degrees. So they're able to use these algorithms basically to reconstruct the room in 3 dimensions. You can then play around with it, move your angle. And at the same time, what you're seeing over here on the right is a large language, it's a computer vision model that is automatically detecting the role of each person in the room mapping out every single interaction that they're having with another individual instrument. So why is that relevant? Because now what you can start to do is say, well, rather than watching an entire video of a trauma, an operation, et cetera, if you want to go back and understand team training and dynamics, all you have to do is actually review the scene graph, highlight the parts of the scene graph that are most relevant for review, and go back and look at those specific elements. You can incorporate vision language models into this. This is sort of the next step of their work, where they're able to take those RGBD images and then actually do what's called visual question answering. So ask specific questions of, give me a description of what's happening, or show me a visual description, so it'll pull out the relevant image to feed it back to you. And then you can further plot out graphically all of the different interactions between the individuals, and then calculate those quantitatively to see if it's having an impact on the outcome of that patient. There are barriers to translation, of course, and there's a reason why these things aren't readily available right now. Number one, the metrics component, right? We talked a little bit about how do we measure things. We all know that not all metrics accurately describe a condition or a scenario, right? So if I tell you a 40-year-old male can play 35 minutes of basketball, the person who shows up on the court might look like this, or they might look like this, and I can guarantee you the performance is not going to be the same. Right? And so we want to think carefully about what are the metrics that we use to measure that performance. So this is an example from the computer vision literature. Very quickly on the left, these are MRIs of the brain. This reference is what the radiologist highlighted as a tumor. This is what the AI model did. If you look at the voxel level, the sensitivity is 94%. This is what the company is going to try to sell you. On the right, though, right, you'll notice there's a lesion in the cerebellum that was missed by the AI model. So if you do your metrics by the instance level of detecting tumors, your sensitivity drops to 0.5, right? And so we really want to ask questions about where these metrics of performance for these AI models are coming from. There's a lot of bias in the data. We've already talked about that in terms of representation, but it's not just representation at the individual level, right? Did you have each type of learner represented? Even what you were trying to assess, there may be class imbalance. A classic example that we see for that in computer vision is finding the needle. I might have 10,000 images of a needle within a data set of 10,000 images, so every single image has a needle in it, but the size of that needle relative to everything else in that image is so small that I'm still class imbalanced on finding a needle, right? So that's going to impact the performance and the way that these models output their determinations. And so it's actually really digging in deeply into the data that you have and the question that you want to ask to determine whether you can even use AI to answer your question or solve your problem. And so to think about that, it really comes down to, as educators, do we even have a system in place that is going to allow us to use AI in a meaningful and constructive way that goes beyond just, I want to read fewer applications, I need to get home because I have all these other things I got to do, I got to operate on people, I got to take care of my family, I got to work out, I got to, et cetera, right? How do we meaningfully assess the outcomes of our training, right? This is a sort of theoretical framework that was proposed by Triola and Burke-Raffel at NYU, which is to say, well, can we redesign how we think about data for training? Can we collect longitudinal data? Can we think about the outcomes in terms of how our learners' performance impacts individual patient outcomes? Can we be intentional about data collection and access to that data? Can we come up with targeted interventions that leverage that intentional data collection? And can we identify the relevant outcomes that matter for us as educators for that generation of learners that's coming up? So in conclusion, can you use AI for training and assessment? Yes, because the access to AI models is increasing and the barriers to its use are decreasing, right? You don't need to be a programmer anymore to use a lot of these types of AI tools. But I think it's really important to ask yourselves, why do you want to use AI? What are you trying to measure? Why are you trying to measure it? And do you have a full understanding of the strengths and pitfalls of these models? And if not, have you partnered with a data scientist or computer scientist who can actually walk you through this? Just like you would never do a clinical trial without a statistician, you probably shouldn't be doing an AI study without a data scientist or computer scientist. And with that, I'll stop. Thank you.
Well, thank you for 3 fantastic presentations. If you're like the two of us, I'm really excited about the use of AI. I'll emphasize one thing that we heard earlier about the Blue Ribbon Commission 2, which specifically said called for reform to address the digital transformation of the field and how to structure efficient progression to competence. So I think all these presentations really lead into that. And I feel very convinced about the opportunity for AI in recruitment, curriculum assessment, and even quality, as you pointed out. I will ask one question before we go ask Dr. Wise. Can you just, I'm thinking about a risk in AI, and I wonder if, maybe I'll start with Dr. T, the risk of uploading all that personal information to a large language model processing. Do you lose some of that privacy? What are the risks of that?
Oh, sure. Okay. Well, thanks for that question, Dr. Joshi. The question was about privacy, and there's two parts that I can address with that. There's a legal component, and then there's an ethical component. So legally, when medical students apply through ERAS, in that fine print, they actually agree that their data can be shared with a third party and transferred to a third party as long as it's for the purpose of recruitment. And that's how Thalamus gets access to their data. And that's how Medicratic can have access to their data. Now, ethically, and I admit I thought about this after I uploaded 1,200 ERAS applications. Ethically, I just gave 2 medical students, one of whom wants to do a competitive surgical specialty, access to very sensitive information. Now, I have to trust that they're going to not use that in a way that's of conflict of interest or is unethical. But that is a huge thing. And what ends up happening, though, is that those large language models actually they get more refined the more data you give to them. And so that's what happens when someone uploads a score module to ChatGPT and is like, summarize this for me so I don't have to read it. And so, it's sort of a brave new world. Like, not only is there a lot of biases in these AI models because of what information is going into them, but there's no regulation of it. And it's evolving at such a rapid pace that, it'll be quite some time before we can catch up to that regulation.
Dr. Wise.
Thank you very much. Check. Hello. I'll just speak loudly. Thank you very much. This is exactly what we had hoped for this kind of an appreciation of, with the tongue-in-cheek title of the session, that trying to simplify this down, it's so incredibly complicated and complex. So really appreciate the great thoughts from each of the speakers. I will say that, WashUNA has access to a HIPAA and FERPA compliance ChatGPT version. So something to keep in mind at some institutions, or some of you may have access to that, that I do think hopefully mitigates some of those concerns. But I'm curious, from our 2 program directors, are you doing anything in particular to put requirements of those who are applying to your programs, just as we're acknowledging the use of AI and reviewing their applications? Are you either putting limitations on that? We heard yesterday, obviously, that a number of folks are using it for personal statements and using it for other parts of the application. We know faculty are using it also for letters of recommendation. Have you all put any statements to your applicants about their use of AI in their applications, and your kind of thoughts and the implications of that? And I will say, just kind of throwing in, when I've used some of these, one thing I would highly recommend folks test out is something called Open Evidence, which is a really nice system when you feed things in and ask, say, ChatGPT to do something, all the citations or hallucinations, which can become pretty comical actually when you do that and ask it to, say, summarize something about diverticulitis. But Open Evidence actually will give you access to the open evidence and real citations in a really nice summary format. And and I think frankly is going to spell the doom of books, of textbooks out there, because you can create a book chapter like that with systems like that. But at any rate, back to my original question about, are you doing anything to kind of assess or ask your applicants to limit their use of AI?
So I got up yesterday to ask that question during that presentation. Like, so I think the issue is like now in ERIS, should we have a disclosure box? Like I wasn't even, they talked about like paying for a writing service, or I had no idea there was such a thing. But should we have a disclosure now on ERIS? Like I used AI or a writing service to help with my personal statement. I don't know. I think we probably should. It makes me nervous, right? Yeah, 'cause I think you can game the system and have ChatGPT, right? So that part makes me nervous. But on the other hand, like there may be some applicants that are really good applicants, but they're just like shitty personal statement writers. And now they get a good personal statement, then you actually then pay attention to them. So for some people, it might be helpful, but overall, it just kind of makes me nervous that, people aren't putting their actual thoughts down on a piece of paper.
Oh, this one. If I could add to that, that's a great question, Dr. Wise. So, I feel like there was this argument when I was in elementary school about spell checking. And
It was calculators for me.
abacus. And so I do think that one day ChatGPT or whatever AI program you're going to use is going to be something analogous to spell checking, where it's going to refine things. And to be totally honest, I have uploaded reference letters that I've had ChatGPT polish for me. That's like my prompt: polish this so that I sound good to you guys, and I can advocate well for the referees that I write. It does scare me in the sense that, if we are using AI to review applications that are written by AI, then what are we doing? And so it does call into that. It's like kind of an existential crisis for us, right? So I don't know the right answer to it, but I do think AIs are going to be like spell checks in the future.
Dr. Tanawa.
Isn't that the way the Terminator started? Wasn't that Skynet?
Thank you. Ruchi Thanawala from OHSU. I'd like to ask what I really consider kind of two existential questions. Me as an informatician data scientist, also directing a surgical data and decision sciences lab. AI software, Dr. Hashimoto, you know this very well, is considered software as a medical device requiring FDA approval for application within patients. And we consider our patients when we seek IRB approval as they are inherently a vulnerable population within our healthcare environment. Similarly, when we do studies on our residents and our learners, they're considered a vulnerable population. How do we see developing as a society regulation for the safe application of these very tools we're talking about with formal structure and regulation within our own, training environment? Secondarily, probably one of my biggest soapboxes and one of the things that I'm driving towards at OHSU and beyond is the actual training of surgeons and surgical residents in the formal science of informatics. I represent one of 79 individuals within surgery that's actually board certified in informatics. How do we actually then establish formal curricula within our training programs to arm our residents and our surgeons to use these tools effectively, just as Dr. Hashimoto pointed out, to question the validity of these models, to question the statistics behind them and the safe application? Thank you.
Dan, you want to take that?
Yeah, well, I mean, your work is obviously like incredibly groundbreaking. I love reading your papers because you really approach this like a data scientist. You are a data scientist, obviously. It's one of the things I want to point out is I was sort of floored. I didn't know that there were things like thalamus cortex and metacratic, but your results totally expected, right? Because of how these things work and so to Dr. Lanawal's point, like some of these are very dangerous, and they're going to become incredibly, they're going to perpetuate the existing biases that are already in place for review. because they don't actually contribute to holistic review. So thinking about that work is important. The other piece about informatic training, so this I tried very hard to put into BRC2 and it got voted down by faculty and residents who didn't want it. So that's also an interesting sort of take. Now that was 2 years ago, I think, when those sort of surveys went out, but I think it's sort of interesting to hear the perspective. Faculty were more open to that being implemented than residents were. Residents didn't feel they needed it. And I don't know, we didn't have enough granular data around whether that was because they were, digital natives or what, but it's an interesting question, but I do think it's an important one. In Canada, it was proposed that it be a new fundamental competency in the CanMeds framework.
Dr. Lal.
Oh,
Hi. Oh, hang on.
I'm so sorry. Can I add to that? Because I think that was a really great question. The first part of your question was, how do we protect our trainees? And I think that is exactly why we have to do what we're doing right now, because a lot of these large language models do have an underrepresentation of certain populations, and it is important to call that out with this kind of research. Now, we do protect the trainees as much as possible, that they're not, there's this understanding that their data is going to be protected, and it is being used for recruitment. But those results also need to be shared with the general public so that these AI models don't perpetuate biases that are inherent in the world. And just to add on to that, Medicratic has partnered with the anesthesia residency programs such that it's like their thalamus. And so you can imagine that they're using something that I've shown to be potentially biased, and they're applying it to an entire cohort of anesthesiologists.
Thank you. I really appreciate the concept of a computer sifting through 1,200 applications, but it's sifting among them based on your personal biases for what you think makes somebody a good resident for your program. But do we know that that's what makes them good for your program or anyone's program? Wouldn't the best AI tool have that information of whatever a good resident or a good surgeon or a successful surgeon is in the end? And then you see all of their applications, and then you can figure out how to rank somebody instead of based on, I'm going to have a USMLE cutoff, and oh, I like the word grit. So I'm not sure that the concept is valid in a use of AI to select the most competent, successful, imaginative future surgeons. It just amplifies our own biases.
But it does it faster.
Yeah.
No, I think that's the danger, right? It's not gonna be more objective because it is based on your opinion and what you put in, right? It'll save me hours. I looked at it this year. Honestly, the biggest reason I didn't do it was because with signaling, I had so fewer applications to look at, so I just thought I'd do it myself. But yeah, yeah, same thing. I'm worried, like, because it depends on what you say you are looking for, and it's just going to confirm what you said you're looking for, theoretically.
Yeah, and what was interesting with my initial experience with this AI was that I told it what I was looking for, and I did a parallel selection, and it still gave me people that were different from what I was wanting to look for. And part of that could be because, maybe I wasn't training it properly, although I sat with the founders for 2 hours to train it. Part of it could be the uniqueness of my program. And part of it could also be because there were certain things that I couldn't customize. I couldn't customize what medical school they came from because we try to use the pipeline of HBCU medical schools for our program. And so that was what was surprising. Like, you would think that it would pick people that I wanted and I was biased for, but it didn't. And I don't think 2 medical students know what it takes to be a great surgeon either.
But it was picking who they thought, right? So it's your bias plus their bias is actually how it's working.
Yes,
But
yes.
I think the limitation that this is exactly what I was going to ask about. I think the limitation you were facing was how the network was trained. like how well the network learns to select what you would select is a function of the training set. And realistically, the training set should be your previous year's applications and the people that you selected for interviews. But like anything in data science, a lot of it is who owns that data. So the real question is like, can we get a large language model sequestered within our system that no one else has access to, that we can feed into our prior year's applications and the ones we selected for interview to try and train our own model to select the people that we would select if we took the time to read them all. But then we need that data from Eris, and we need servers to implement that individually, or we need, and the NRMP to provide that in siloed versions for each program to train their own model for what they would select. And that's a massive project. But we're not training the networks correctly. We're letting 2 medical students decide how a 2-hour conversation with you can train a network to replace 26 days of your work. That's just not going to happen.
Yes.
We'll try to get 2 quick questions.
I had a related question / comment. My name's Gracie. I'm one of the surgery residents at Penn. We have the privilege of getting to interview people during our administrative resident years. And so I think that's been like a very insightful process this year. And I do think that we have, as humans, imperfections in the way that we are able to assess based on someone's application, whether they're going to be a good fit, whether they're going to be successful at our program. I was wondering whether there have been any efforts to use AI to assess retrospectively our own maybe accuracy in that. If we look at maybe our graduating chief residents, how well did we do, looking at their applications, and how representative were their applications on paper on how successful they've been in residency?
We were just talking about that, right? Like what you want to do now is look at your residents who are awesome.
Yeah.
And then what did they look like 6 years ago, right? Like I have 2 chief residents right now that are fantastic. One you knew 6 years ago was going to be fantastic. The other one you were like, oh, but they've turned out good. So how can you take residents that are doing, or the ones that are doing poorly, and how could that have been predicted? That's what we would need to know.
I think we're at the end of the session. If you can catch them afterwards. Thank you so much, the 3 of you, for a great presentation and great questions. Thanks.
Thank you.
You have great, I've met your fellows before, Taylor and John, so that's why I get that.
Personal statement.